Good morning, Alcyon. Alcyon. Hey, it's lesson 7-5. We're talking about functions. You've seen this on your CAS where it asks you to put things in function notation. Well, what is a function? And that's what we're going to learn here in 7-5. You can read the big idea. It's right there. The vocabulary is fairly extensive for this one, and you need to know what these things mean. So what is a function? It's very specific. We've got two areas of definition. One is a sort of a general idea of a function. It's a set of ordered pairs where no two ordered pairs have the same x value. So that's one, and that could be applied to all kinds of things. The other is a more of an algebraic definition of it that describes formulas, and it's basically saying there's a correspondence between variables so that for any given independent variable, the x variable, there is only one and only one y variable. And I'll show you a little bit about what that might look like when we're getting into graphs. So go through the definitions, make sure you know what these all mean. You shouldn't be surprised if you see some of this vocabulary on your mastery quiz. And as you read through it, you might reach a conclusion about what is important and make sure you know that. Okay, so language of functions. Let's move on. Take a look at example 1. This is consider the square root function where y equals the square root of x. Which pairs non-negative real numbers with their square roots? Give the domain. Well, we were asked to define domain. What is it? The domain of a function is the independent variable. We take that to be the horizontal component on the graph, which is the x variable in this case. So x typically is our independent variable. So x happens, then we get y. So y then would be the range or the dependent function. So the domain are the possible x values. So let's take a look at that. The domain for this would be all, let's see. Well, we can't have negative values in there. We're not working with imaginary numbers at this point. So for this, we would have non-negative real numbers would all work for this. It's not just integers, not whole numbers. So we need real numbers, but they can't be negative. So that's our domain, non-negative real numbers. If this is true, then what's the range going to be? I know it doesn't ask you for that there, but what will the range be? And the range would be all same thing, non-negative real numbers. Now, they're not always the same. We're going to see that when we do some calculations. So just in this case they are. It may not always be that way. For b, find the value of the function when x equals 9. What this is asking is the function is y equals the square root of x. If x equals 9, y equals the square root of 9. The square root of 9, where's my calculator? Oh wait, we know this one. Square root of 9 is 3. So the answer is that y equals 3. Got the domain. We did a calculation using the function. We're still using y. When we get to the next chapter, we'll get to the function of x notation, which equals 3. And the function of x equals y. This is just simply our y component. Okay, next example, example 2, we're asked to find what are the domain and range of the functions described by the equation y equals a negative 2x plus 7. Well, the domain, let's ask ourselves, is there any numbers that x can't be? And the answer to that is, well, no, any real number is going to work. It can be negative, it could be positive, it can be zero. So our domain is all real numbers. And our range, given that this could be anything, there's no constraints, there's nothing that y can't be, so y is all real numbers. So any value of y is possible given that any value of x is possible. Excuse me. Example 3. In lesson 7.2, the equation y equals 5,000 times 1.04 raised to the x power describes a function that models the total amount of money y in a savings account after x years. If 5,000 is invested at an annual yield of 4%, what is the range of this function? Okay, on to example 3. In lesson 7.2, the equation y equals 5,000 times 1.04 raised to the x describes a function that models the total amount of money y in a savings account after x years. So y, did I do it over there? Okay, y equals 5,000 times 1.04 raised to the x. So 5,000 times 1 gives us our original amount. 5,000 times 0.04 is our percent yield, and asks what is the range of this function. Well, we want to know what are the possible values that y could have. Well, what can x be? Well, x is going to be 0 or positive integers. So it could be 0, 1, 2, 3, and so on, dot, dot, dot. And y is going to be the result of that. So the range will be a set of values that can occur in this function, and the minimum value is going to be when x is 0. When x is 0, 1.04 is 1. 1 times 5,000 is 5,000. So at the beginning of time, it's simply $5,000. I could calculate the rest of them, but I now know the minimum, and so I know now that the range of the function is that y is greater than or equal to 5,000. It could be anything over 5,000, 5,000 and up. It won't be below 5,000. We're not going to have a fractional x or a negative x. So we're never going to drop below 5,000 for this calculation. That's it. That is the range of this function. The domain of the function, we defined it here, is related to the savings, and so it's integer values, positive integers, 0, 1, 2, 3, and 0, 0, 1, 2, 3, and so on. Relations that are not functions. The word relation, it's in your book on page 428, describes any set of ordered pairs. It's possible to have a relationship between variables that are not functions. This happens when the first variable in x in a relation corresponds to more than one value in the second variable. Well, here's a quick example of something that is a relation, not a function. I draw a circle, and it's possible that I have some value of x, let's choose 0, and when x is 0, there are two possible values of y. It's not a function, because remember, the x only maps to or only results in one y variable. So this is a relation, not a function. See if you can think of some others. There might be some other curves that could give you something that is a relation and not a function. The next topic here is functions whose domains or ranges are not sets of numbers. Well, that's in the text. It talks about blood types. For every person, people are X values. The Y value is what type of blood you have. For any X, there is only one possibility that you could have. You're going to be one of the various blood types. Other people could have that, and that's okay. If I had a value where for a given X, that other X's had the same value, here's a straight line, this is Y, this is X, all of the X's have the same Y value, but this is a function because each X only maps to one unique Y value. That's it for this work in 7.5. I think there's a bit of repetition to it. I do know you need to know the definitions. You need to be very clear about domain and range and independent variable and dependent variable. Make sure you have that information in your head and locked down. Okay, I'll see you on the next lesson.